1. In the Space Lab Life Sciences 2 payload, 14 male rats were sent to space. Upon their return, the red blood cell mass in milliliters of the rats was determined. A control group of 14 male rats was held under the same conditions except for spaceflight as the space rats, and their red blood cell mass was also determined when the space rats returned. The project resulted in the data table in Table 3, this table over here, or the Space Lab dataset. Does the evidence suggest that the flight animals have a different red blood cell mass from the control animals at the 5% level of significance? So based on this question, we have our null hypothesis that the mean of the spaceflight rats would be minus the mean of the control rats is supposed to equal to 0. And the alternative. Do you want to know if they have a different amount? These means then would not be equal to. So the mean of the space rats is not equal to the control rats mean. Okay? And the data set for this was this particular data set. And I'm just going to copy and paste that into this Excel document over here, which has our template in it for this particular test. This gives us our t statistic here of negative 1.437. So I'll write that here. Negative 1.44. And the p-value. Is going to equal to, it's off the screen here, so let me move this over. This gives us a value, oh, wait a minute, I need to change my test. This is a not equal to test. This gives us a p-value of 0.1642. As a p-value. And the conclusion that we could write for this, and let me attempt to expand this a little bit so I have more room. This conclusion would be at the 5% level of significance, since that p-value of 0.1642, that's well greater than 5%. This would be a we do not have evidence to suggest that the mean red blood cell mass of the space flight rats is different from the mean red blood cell mass from the control rats. And then the 95% confidence interval we also have in this Excel document. Since we want a 95% confidence level, that was this cell here needs to be 95%. And that gives us the confidence interval here. So the lower bound of negative 1.34 and upper bound of 0.24. So the lower bound is negative 1.34 and the upper bound is 0.24. And the interpretation of that confidence interval is we are 95% confident that the difference between the mean red blood cell mass for the space flight rats, the difference between the mean red blood cell mass for the spaceflight flats and the mean red blood cell mass from the control rats is between negative 1.34 milliliters and 0.24 milliliters.